Right, so online and WebAssembly, why bother, you ask? And I was asking myself. So, I mean, online is already running in the browser, and WebAssembly, as you all know, is a bit of an odd one out. It's relatively young, then again, not that young. I think 2017, the kind of preview phase ended. But still, why bother? It's not all quite redundant because online is already in the browser, and why add something else to that? So that's the standard architecture for an online instance. You're all aware of that. You know that since many years. There's a relatively lightweight browser front end and a relatively speaking, document and the load is on the server, and all the processing is done there, or most of the processing with the document. And well, you can spot the maybe there's a little problem here because well, there's a network in the middle, and networks are kind of messy, and it's not under your control. It's somebody else there, and several parties there, and then there's proxies and caches and latencies and stuff like that. So perhaps client server sometimes poses some challenges because, yeah, you depend on external network latency and throughput, and sometimes there's a tunnel, sometimes there's an airplane, and sometimes there's wireless connections that have fun aspects when they bundle packets, and it's all a bit messy. The other thing, it scales linearly with the server and CPU. So if you put your documents there, load them on the server, and you double the number of users who probably, or active users who probably need to double the CPU, like number of cores, and also the RAM on that server, which could be worse. I mean, linear scaling is not a terrible thing. And the other thing is, of course, there's no easy offline capabilities if you do that, if you use that setup. So yes, enter WebAssembly LibreOffice. What you see here is a number of screenshots from demos that we did. Please bear with us there. There's another talk right after this one. Moritz will tell you a lot more about the details here, what we did. Please bear with us while we figure out names and brandings and how to integrate that. So this Zeta.js probably is going to be renamed into something like Cool.js or something similar. But what you see is something that is actually LibreOffice rendering on a Qt5 driven HTML canvas, so that is like native pixels there in the browser, which the entire Office suite there, plus a little JavaScript wrapper, so that's actually JavaScript GUI here. So that's a setup that plausibly could be reused in some way or the other. And it's actually not terrible in terms of size, scale, being heavyweight. So it's, as I said, 2017, the preview phase ended. So in the, let's say, with web speed, we could say this is now enterprise technology, well established. All the major browsers support that, even Safari. And you see, like here, there's some profiling page there. So at this, for this document, it's 72 megabytes on the heap that's used. So it's between 50 and 100 megabyte per document in the browser. And the WebAssembly binary itself is also not terribly large, although it's also not lightweight. It's a far cry from a lightweight front end like online right now has. Right, so where does it end us with? The upsides for WebAssembly are it runs fully client-side, so all of it. So you don't need anything on the server for this setup. So you only need some static WebAssembly binaries somewhere and a little bit of JavaScript. We managed to put this all on a die. So the WebAssembly binary itself is 32 megabytes right now for this pure LibreOffice one, and 50 megabytes of data, which can probably also be shrunk a little bit more because there's a lot of fonts and a lot of GUI files, etc. in there that LibreOffice needs by default. It's using the browser cache because it's compressed nicely after the first download. The first download you get to pay that price, but after that it's usually cached. And for the common use case, single user, one document, that there's 0 server load and 0 server memory that you need for that because it's all in the client. And there's no round trips, no extra latency for typing, so you kind of cut out this annoying network problem there. And implicitly, of course, with that, it's offline capable. This one, kudos to Kalen for this nice graphics. That's the current setup. So there was a demo that was presented last year at FOSDEM with that technology, which is actually reusing the same architecture as been used for mobile, which means that's actually the WebSocket daemon running in the same process, serving the tiles via some virtual socket. So you have the front end, the JavaScript front end, and the back end somehow in one browser tab running there simultaneously. That's existing, that's working. That's using the tiled rendering versus this Qt 5 canvas rendering. So those are the two ways to get pixels on the screen. The status there, as I said, FOSDEM 24, there was the demo working. We did then quite a lot of work on the Allotropa side with the Zeta.js, with this nice JavaScript UNO binding there, and a lot of productizing and optimizing. And long story short, where we are now is that we have quite a number of options, and we got to figure out like how to do that in the best way. Probably it's going to be CoWASM with a bit of getting the most recent improvements that we did on Zeta.js into that. Hopefully also being able to offer the UNO bindings there for the client side, so people can have a bit more, bit deeper integration into and programmability when using that as a plugin. So next up then is getting all of that product ready, and I'm quite excited and looking forward to do that. Thank you.